All right. Last time we have talked about measures of central tendency. That is mean, median, and mode. Today we're going to look at measures of variability. Measures of variability are also called measures of dispersion or measures of spread. These are indices that shows how scores are different from each other. For instance, you have a set of scores, maybe about 5 scores, that has 12, 12, 12, 12, 12. You can see that the scores are the same. The highest score in this case is 12, the lowest score is 12, and so there is no variability. But in a situation where you have 30, you have 20, you have 15, you have 5, and all that, you can now see that the scores are not the same. There are measures that shows how those scores differ from one another. Those measures are called measures of variability or measures of dispersion. Sometimes it's called measures of spread. And that's what we have been looking at now. Now there are different types of measures of variability. You have, there is the range. Range is there. Quartile range is also there. Interquartile range, semi-interquartile range. These are all measures of variability. You also have mean deviation. Mean deviation is also part of measures of variability. Then you also have standard deviation as well as variance. Variance or standard deviation. And today we want to focus on some of them. Now, the first one is range. Range is the commonest measure of variability or spread. It is also the easiest to calculate. It's not difficult to calculate. And the formula for range is R is equal to HS minus LS, where R is range, HS is highest score, LS is lowest score. Now there are steps one can use in calculating range. The steps are here. Number one, rearrange the scores. That's the first one. Rearrange the scores. And then step 2, identify the highest score, which is the HS. Step 3, identify the lowest score, which is the LS. And step 4, subtract LS, which is the lowest score, from the highest score. Now there is an example here. Calculate the range of the following distribution. Calculate the range of the following distribution. You have 12, 20, 25, 10, and 5. Now, in this case, remember the first step said we arrange the scores either in ascending or descending order of magnitude. Now, we have arranged the scores in descending order. That's from the highest score to the least score. The highest score here is 25, followed by 20, 12, 10, and 5. And so in this distribution, the highest score, which is the HS, is 25, while the lowest score, which is the LS, is 5. And therefore the range, which is the highest score minus the lowest score, is 25 minus 5. Therefore the range is 20. And so the range for this distribution is 20. Like I said before, range is very easy to calculate. You just identify the highest score, identify the lowest score, subtract the lowest score from the highest score, and you have gotten range. Now, range has some characteristics. Range has some characteristics. One of it is that it is easy to calculate. Range is very easy to calculate. Another one is that range is easily available for making decision. When you want to make a quick decision, what is required, what you use is range. And then the third one is that it is useful if the maximum variation in the distribution is required to be determined. In a situation, they say, what's the highest score? What's the lowest score? In such a situation that they want you to determine the maximum variation, the range is required. And then finally, range goes better. Range goes better or is used better with the mode. And then there's also some problems associated with range. The first one is that range is unrefined. Why? Because it depends on only two extreme scores. It does not bother with other scores in the distribution. It's just not about the two extreme scores, the highest score and the lowest score. And then number two, it does not tell anything about the variability of the majority of scores in the distribution. If you have 10 scores, for instance, and you have the highest score and the lowest score, the other 8 scores, how they vary, is not the concern of mode. It's only concerned with the highest score and the lowest score. And then the third one is that the value of range in a distribution is greatly influenced by the presence of two unusual extreme scores. The value depends on the two extreme scores, the highest score and the lowest score. That's why you can have 5 sets of distribution with different scores, but the range of those scores will remain the same, meaning the range most times is unstable. And that was why in the characteristics we pointed out that it is better used with mode. Of course, you know that mode is a measure of central tendency that is very, very unstable. And so mode and range are both unstable, and of course you know that birds of the same feather flock together. And so because both of them are unstable, they go together. Another measure of variability is the variance. Variance and standard deviation. Both variance and standard deviation are based on the mean. They use the mean as a reference point. While standard deviation is a square root of the variance, variance is the square root of standard deviation. Let me say it again. Standard deviation is the square root of the variance, while variance is the square of standard deviation. Both of them go cap in hand. Standard deviation is the square root. Variance is a square of standard deviation. They go hand in hand. Now, these are steps in calculating variance and standard deviation of ungroup data when frequency is not involved using raw score. The method we use here is called the raw score method. There is also the mean deviation method, and there is the coding method. But the method we are using here is called the raw score method. Now, what are the steps in using the raw score method in calculating variance and standard deviation of an ungroup data that does not involve frequency? Step one is to determine the range or inclusive range. Of course, what I've been saying is the reason is to know whether the data is grouped to be grouped or ungrouped. And then step two, form 2 columns. And step 3, arrange scores in column 1 and so on. Step 4, square each score in column 2 and so on. And then step 5, determine the variance. Determine the standard deviation using the following formula. Now look at this formula very well. If you remove this square root sign, it is variance. Now if you put this square root sign as it is standard deviation. Once again, if you remove this sign, square root sign, the formula refers to variance. But if you leave it this way, the way it is now, is the formula for standard deviation. Now there's an example here. Calculate the variance and standard deviation of the following scores. Like I said, calculation of variance and standard deviation go together because the standard deviation is just the square root of variance. And so these scores are given here. There is a distribution here: 4, 10, 5, 6, 8, 9, 10. Now, first, determine the inclusive range. 10 minus 4 plus 1. And that will give you 6 plus 1, which is 7. The inclusive range is 7. Once you have determined that, the 7 is less than 15. And so this data is ungrouped. And again, the scores are just few. There is no need to group them. Now, you now form 2 columns. Here is score, here is square of each of the scores. Now, these scores in the distribution have been arranged in ascending order of magnitude: 4, 5, 6, 7, 8, 9, and 10. The square of 4 is 16, square of 5, 25, square of 6, 36, square of 7, 49, square of 8, 64, square of 9, 81, square of 10, 100. Now, if you add this together, the score will give you 49. If you add the squares together, it will give you 371. Now, the variance therefore is sum of the squares minus the scores squared all over n minus 1. Then sum of s squared refer to this 371, while sum of x squared is this 49. And that's why you have this 371 minus 49. Okay, 371 minus 49 squared over 7, all over 7 minus 1. And that will give you 371 minus 2471. If you square this 49 squared, it will give you 2401. Divide by 7, all over 6. How do you get this 6? 7 minus 1 will give you 6. And that will be equal to 371 minus 343. That's dividing this 2401 by 7 will give you 343 divided by 6. And when you do that, 371 minus 343 divided by 6 will give you 4.67. This is square variance. This is variance. Now the standard deviation is equal to the square root of that variance. And the square root of 4.67 will give you 2.16. So the standard deviation for this distribution is 2.16. The next time we are going to discuss, we'll talk about how to calculate the variance and standard deviation of ungroup data involving frequency, as well as the variance and standard deviation of a grouped data. God bless you.